Perfect. Yeah, looks like we are live. Hello, everyone. Welcome back to another workshop by the Taiko Grant Factory team. Super excited, like always, to kick this one off as well. We are getting closer and closer to the finish line. Let only 27 days left for submission, and a lot of exciting things are yet to come up. We are almost on the final week of the workshops and presentations. But kicking this off with Jorin, who will talk more about how the workshop is going to be, but just summarizing how it's been and what the total price pool is. The total price pool stands at 100K USD, divided into three tracks: work hard, play hard, do good, and an additional 10K allocated to different ideas such as best business ideas, community support, impressive grant proposal, etc. And a lot of opportunities even after we get done with this hackathon for your project, for your idea to take it to the next level. So, yeah, I think if you've been thinking on something to build, this could be your chance to kick it off with the Taiko Grant Factory. But without taking a lot of time, Joran, I would love to pass it on to you and talk about, yeah, what do we have in store for today?
Perfect. Thank you so much, Mishika, and thank you so much for the DoraHacks team for supporting us and the folks behind the scenes that are making it all happen. Yeah, so the Grand Factory is all about empowering and inspiring people to build new businesses to deploy in the Taiko ecosystem. And so we have this hackathon that's finishing in the next less than 30 days, like Mashika said. But the idea is that we're setting you guys up to be able to unlock funds after the hackathon. And so that's where the grant part of the hackathon comes in. So not only are you going to be able to unlock a chunk of funds for your hard work during the hackathon period, but we want to see what your vision is beyond the hackathon so that we can give you more funds as you reach milestones further on. And so there's going to be a workshop on how to write a grant and submit a grant. So keep an eye out for that. But that is an important step to really empower you to build this business and have the support that you need long term. Now, getting into the workshop that we have today, we have my colleague Jünger here. He is the top researcher, I will say, at Taiko Labs. I really enjoy reading his articles. You probably have read some of his articles already. He produces really high quality work and just gives you great insights into not only Taiko, but the general blockchain Ethereum space. And so today we're going to take a look at the current landscape for rollups, as well as what particularly what base rollups bring to the Ethereum landscape and how we add value back to Ethereum. So without any further delay, Jünger, take it over.
Hey everyone, thanks for having me, Joran. It's all good right now. You can see my screen.
Good to go. Yep. Yeah.
Wait a second. Okay, that's it. Yeah, hi again. Today I'm gonna talk about the current landscape of rollups and how base rollups contribute to the rollup landscape. So let's start then. Today we are embraced the rollup centric roadmap. It 4 and 5 years ago. So previously we tried something to scale Ethereum. There was sharding, but it was very hard to implement. But now we have rollups and very easy to build and the easiest way to inherit Ethereum security. Today we have at least 200 rollups and it will grow day by day. Every day it's coming. We are seeing any rollups. So, but we scaled Ethereum. So today we have 200, 300 TPS at second. So we can definitely say we scaled Ethereum. Yeah, the rollup-centric roadmap gave us an endless experiment field. We can do anything. We can implement different VMs. We can use different methods. It can be anything. It's an endless space. So today we have, as you see here, alternative VMs like Fuel, Fluent, ZK VMs like Aztec, Starknet, and ZK EVMs, Lineas, ZK Sync Scroll, and also parallel EVMs, Mega ETH. So, as I said, we can do anything, any idea to implement as a rollup. But every design on the distributed system will cause some problems. So this is understandable. Everyone can understand because we have to choose something. So rollup-centric roadmap, as I said, we embraced 4 years ago, 5 years ago, and now we have some problems. The first one is lack of interoperability. That means each rollup is siloed. So there is no real connection between them. You cannot do transaction. You cannot send anything between each rollups. And this is also caused liquidity fragmentation. Every rollup has own TVL, so these TVLs cannot move directly to from one rollup to another rollup. And also philosophical disconnection. This is our first priority to obey Ethereum as a philosophical rule. So yeah, we have some solutions to achieve this interoperability and unified liquidity and plus philosophical connection. So the first one is shared sequencers, the second one is real-time proving, and third one base rollups. Let's start with shared sequencers. So shared sequencers basically says, I want to build a network from scratch. This network has own validator set, and this will introduce new cryptoeconomic security. So if a rollup participate into shared sequencer network, that means this shared sequencer can build all participated rollups blocks. That means you can have interoperability between participate rollups. So by opt-in to shared sequencers, rollup can take advantage of decentralization, pre-confirmation, and as I said, cross-chain atomicity. But yeah, at this marketplace, I mean, shared sequencer also, we can call them marketplace. So rollups can put a reserve price for their blocks because, for example, rollup A have an MEV per block 1 ETH, so they don't want to put less money to that. So they have a right to put a reserve limit. So basically, as you see here, these validators secure the network. Shared sequencer can build the participant blocks at the same time. So we will have a atomic composability between all participant rollups. That's good in theory, but it has some costs. So the first one, they are business-to-business models. So what does that mean? You have to go to the rollup operators and rollup teams. Then, do you want to join to my network? Do you want to join here? So you have to run these business models individually with everyone. So this is not so sustainable. It has some problems because you need to create a network effect because every participant rollups will add value to the shared sequencing layer. So the other problem is they introduce security assumptions. So it's obvious they will have less security than Ethereum. I say exactly Ethereum, but I will come and mention it again. And also, as I said, network effect difficult to maintain because any rollup can left from the chain, then you will lose your network effect. And plus yet another layer. So personally, I hate the word of modularity because every layer adds delay to the chain. For example, we call finality when you do transaction on Ethereum L1, you have to wait maybe 20 minutes to your transaction be finalized, and all of the layer, like shared sequencer layers, will introduce new delay to the finality, even if they give a finality to L2 users, but real finality, it will be delayed. The second one is real-time proving. This is very important and it's inevitable. It will happen in any case. So basically, but we need to snarkify all of the rollups to achieve this composability. This is real-time proving. So when we have real-time proving, as you see here, rollup A, rollup B, rollup C, they have atomic level composability at some slot, at some durations at the slot time. Yeah, for example, rollup A, rollup B, they have composability at this time. So you can do transactions between each other. So you can send money from rollup A to rollup B instantly without bridging, without waiting anything. Yeah, as I say, the real-time proving will be here at some point. It's inevitable. But we need ZK hardwares. We call them ASICs, app-specific circuits, to make easy ZK operations, such as FFT, NTT. We need to accelerate these calculations. And also we have ZK acceleration through Naive-proof methods and softwares. As you see here, we have SciSig, we have Axial to build ZK hardwares. It can be ASIC and FPGA. There is some trade-offs, all of them. And also we have ZK acceleration by Ulvatena, Ingonyama, and many more. Yeah. The last one is base rollups. So main definition of rollups is using Ethereum as DA. DA means data availability layer. So you have to send your data to Ethereum, so you will be a rollup. This is the main definition. But also using Ethereum as sequencer is possible, but it has some cost. It has some trade-offs. We will go deep. So as you see here, basically, rather than centralized sequencer will decide the order of the transaction, the L1 itself can do that for me. What does that mean? So as you see here, there's L2 searchers here. These you don't need to think complex. Just, for example, you can say MetaMask. MetaMask see the transaction and send them to the mempool. Mempool is the pool that transaction get in. So L1 block builders, the Taiko block builders, can bundle that block and send them to the L1. But these L2 block builders is also part of L1 pipeline. So my blocks are composable with Ethereum L1. But in other rollups, in centralized rollups, they bundle their transaction, they build them blocks and send them directly to the L1. So they can get all MEV, all revenue, but in my design, L1 can take MEV from my blocks. This is very important. I'm adding real value to Ethereum L1. This is very important. Yeah, every design, as I said, there's some trade-offs. The pros is you don't need to implement, you don't need to build sequencer from scratch. There is no engineering efforts here. And also, if you build a centralized sequencer, you have to pay money to your cloud services. It's a very high amount of money. So it's very hard to maintain. It's very costly, but you can get revenue from transaction, but still costly, and there's effort requirements in terms of engineering and also economy. The other one is, this is the main process, the base rollups, inherits full security and liveness of Ethereum. So for example, Ethereum is live, Ethereum is continue anyway. This is the most secure in terms of crypto economic security chain in the world right now. So the crypto economic security coming from staked amount of ETH. So I don't exactly remember the amount of ETH that's staked, but maybe 500 billion, I don't know. And this is actually the crypto economic security. That means the cost of attack to the chain. So if you have high cryptoeconomic security, that means someone need to that money to attack to the chain. So there is no, they will have no amount of ETH, so they need to buy from market, and ETH price will go up. And this is the exponentially growing cryptoeconomic security. This is the beauty of Ethereum. And by being base rollup, you can inherit all of this security and lightness of Ethereum. This is very important. And the other one is MEV flows to the L1. The Ethereum L1 can take advantage, can take revenue from for example, Taiko's blocks. This is the very important, because there is the current landscape of rollups. There is no value transfers to the L1. This is the other problem. And by being base rollups, you will have decentralized sequencing and permissionless. Anyone can propose a block. It's not very efficient. I will talk that, but still permissionless. And this is the main idea of blockchains. So we are building blockchains because anyone can participate, anyone can contribute, anyone can take advantage. So this is the main idea of blockchains. But as you see, the current landscape of rollups, it's very far from here. But by being base rollup, you will have all of these good stuff. The bad thing, the downsides, it's bad UX. So limited block times, 12 seconds because of Ethereum. Ethereum has 12-second block times, so your minimum block time is 12 seconds. So it's not very user-friendly. So this is the first constraint by being base rollups. The second one is limited revenue. It's not very profitable. I will talk that again. And also permissions attacks. So centralized sequencers can defend the chain from the malicious attacks. But by being base rollups, so anyone can propose a block. So anyone can, it's permissionless block building. So attackers, malicious actors can attack to the chain if you have a bug on your contract. So this is the downsides. How we deal with it. So we have downsides, but we need to handle with all of that. The first one is pre-confirmation. We call them based pre-confirmation. Basically, we use L1 proposers to provide pre-confirmations to L2 users. So this is another beauty of using Ethereum as a part of your chain, because as you know, centralized sequencers, they just order themselves to the transaction. So you need to trust the rollup entity, rollup team, to not front run your transaction. But by being base rollup, you inherit, and also by using base pre-confirmation, you still inherit the lightness of Ethereum. But good to mention here, it will less secure and less live than native base rollup, because you need to opt in through registry contract and gateway to be a pre-confer. We call them pre-confer to pre-confirmation providers. We are very, very close working with Titan Nethermind to pre-confirmation testnet. So it will happen in Q4 until this year is finished. The profitability, as I said, there is a limited revenue. It's not very profitable base rollups, because the current rollups. So let's talk about that. When you do transaction on Ethereum, you are paying base fee plus priority fee. Base fee is stable. It's an exact amount of money you have to pay for each transaction. But priority fee is, so I want, for example, faster transaction, faster inclusion. So I need to pay priority fee to the sequencer. So sequencer will take my transaction faster. So pay high and get fast transaction. This is the very easy. But by being base rollup operator, I need to separate base rollup operator and base rollup proposer. Yeah, base rollup operator can also be a base rollup proposer. But let's talk about the proposer side. Yeah, you will have base fee, and this is exact amount of. Yeah, the base fee is the exact amount of money, so it will go to the base rollup operator. It will go to the Taiko Labs treasury. Yeah, you can pay priority fee to get fast inclusion, and you can also build the MEV. You can earn the MEV revenue if you have base rollup proposer, but it's limited because proposer can change every time. So now I'm proposing, next time Jorin proposing blocks. So there is still limitations. So this is the limitations of base rollup. This is the before. This is the native based rollups. But in the after, so for example, let's talk about Taiko. With upcoming fork, upcoming upgrade to the chain, the large percentage of base fee will go to the base rollup proposer. So it will increase the revenue of proposer. So everyone will be happy. And also, he will or she will continue to take priority fee. So it will continue anyway. Also, MEV still will continue. But as I say, when we bring base pre-confirmation, users now need to pay pre-confirm fee to pre-confirmation provider to get fast inclusion. And also from operator perspective, for example, at Taiko, we are subsidize the cost of transaction from the users. So, but we need to stop at some point because our money is limited. We cannot do this to the end of our life. So, yeah, this pre-confirmation also solve the profitability of base rollups. And this is the we can say end game of economics of base rollups. And the last one, the downsides, is security. As I say, it's permissionless attacks. Anyone can attack to the chain. For that, we have multi-proof structure. So, as I said, centralized rollups can protect the chain from malicious attacks, but I cannot. So, I need multi-proof system. I cannot trust just one proof system. I need to increase this type of proofs. This is the main idea. And this multi-proof structure can be happen by different implementation by different teams. That means, for example, we have Get client, Go Ethereum clients. We have Rust Ethereum clients and many more. So these all implementation, so even if one client has bug, so the other one won't. This is the easiest multi-proof system. And also, I can separate my proof type of proofs. It can be validity proof, it can be fraud proof. As you know, the rollups we can separate rollups as two parts. One is validity. We are calling them ZK, but there is no ZK. We call them ZK just a term, but the real name is validity rollup and plus fraud proofs. And we can separate the validity proofs as ZK plus SGX, and we can separate again ZK as snark and stark. This is the main idea of multi-proof structure. Yeah. So as I say, I cannot trust just one proof system, because if this proof is broken, so my chain will be attacked. So this is not sustainable. So I need multi-proof system. So we have currently SGX plus Guardian proof. Currently we have these ones, but in near future, I can say Q4, we will have ZK proofs. This image is old. This from our old blog post, but it's still valid to understand multi-proof structure. So every block proved by SGX. SGX is a type of TEE proof. TEE means trusted execution environment. So there is private area on the hardware, on Intel hardware. So this private area, non-addressable. You cannot reach directly to the private field. So you can run any code in this private field. So you will have a type of proof. We cannot call them as a real proof, but still we can trust them. Because if someone doesn't believe to the SGX prover, anyone can contest. But you have to put a bond, put a Taiko token to contest the proof. So after that, you need to have ZK proof. So let's think about this scenario. The block is proved by SGX, and someone didn't believe, and he said, I don't believe you. I need high tier of proof. This is ZK proof. So ZK prover will put a real proof of the block. Then the SGX prover will be slashed, and this amount of money will distribute to contester plus ZK prover plus DAO treasury. This is the live action of Taiko's economy. This system gives us very robust security. And also good to mention here, we have Guardian proof. This is multi-signature is belong to Taiko Labs, but we want to leave that multi-signature at the end of the day. And also plus, we don't want fully trust SGX, and end game of Taiko, it will be fully depends on ZK proofs. This is because ZK is end game. It's a cryptographic magic, and it will help to fix all of the wounds of blockchains, even Ethereum and even Rollups. And as I say, we embrace TEE proofs. Currently, we have SGX, and I'm going to first integrate Amazon Nitro and Intel TDX. For ZK proofs, we have Risk Zero and Succinct Labs ZK VMs. And in Q4, we will gradually start to prove blocks with ZK proofs, Risk Zero plus Succinct ZK VM. And yeah, at the end of the day, we will prove every block with ZK proofs rather than prove every block with SGX proof. Yeah. As a summary, it was very deep. We dived a lot to Taiko chain, but as a summary, everyone tired of centralization of rollups. So every rollup team say, yeah, we will decentralize our chain for 3 years, 2 years, 4 years. They are still saying that, but there is no enough incentive to decentralize rollups, because, as I say, they can earn money from priority fee. So if you pay high amount of money, they will earn a lot of money. So for example, let's talk about optimism. 80%, maybe 90% of money coming from just priority fee. So if they will decentralize the network, So this priority fee will be reduced. Not totally, but reduced a little bit. So they don't want to do it. Yeah, but if you be base rollup, you will have one day, you will have decentralized blockchain from day one. This is the very easy. You don't need to implement. You don't need to design sequencer from scratch. Just some small line of code. Then you will be base rollup. So this is the beauty of base rollups, and plus we want composability. So every money, every TVL that rollups own is siloed. So there is no connection. But as I said, shared sequencer and also, real-time proving will be an option, but shared sequencer, it come with cost. Real-time proving is a little bit far from now, maybe 4 years, maybe 5 years later. But base rollup is live now. Taiko is the first and only base rollup, and there is upcoming base rollups like Spire Labs, Unify. This is some examples, and there are many more. And the first problem is, for example, Optimism say, come and join to my OP stack. Let's solve the fragmentation. And Arbitrum Orbit say, come join my stack and let's solve the fragmentation. But it's not work like that. So I don't want to join your stack. I don't want to be a part of your framework, your SDK. So this is not very natural way to be solved the composability. But by being base rollup, you will have full composability with Ethereum L1 plus other base rollup. This is the very credibly natural way to solve composability in our mental model. Yeah, that's it. Do you have any questions?
Yes, amazing, Jünger. Thank you so much. I have some questions, and there was a couple questions from the audience. But yeah, I just want to thank you for such a deep and thoughtful talk. I learned a lot, and yeah, I want to dig a little bit deeper into some of the things that you brought up. First of all, maybe like a more personal kind of philosophical question is MEV. Is it a feature or is it a bug?
Very good question. But every part of the world, there is some extractable value, right? So for example, arbitrage. If there is no arbitrage, there is no stable price. So this is the main idea of every economy. So from my perspective, MEVs cannot avoidable. It will be happen anyway. So yeah, it's not a bug from my side, but there is arbitrage is a good side of the. Let me put here. Arbitrage is a good side of MEV. There is bad MEVs. There is good MEVs. There is natural MEVs. So we cannot say all MEV is bad. We don't need MEV. We hate MEV, but we need that because of the stable prices. That's my perspective.
Yeah, that makes sense. I could definitely see both sides, and I think I flip-flopped myself on the topic. I think from a larger blockchain kind of ethos that it can be looked down upon as exploitative, right? But then to your point, like you were saying, arbitrage is going to happen anyways. I guess should it be baked into the protocol so that the ones that are running the nodes get that first front running kind of advantage? I know there's some architectures that aim to mitigate or minimize or even remove that altogether. So what are your thoughts maybe around that?
Yeah, there will be always some options to remove MEV, increase MEV. So yeah, it's good to see everything at the table. So we need all of them. But at the end of the day, the value need to exit from somewhere. This is the closed economy, so it's unavoidable from my perspective. But it's good to see some experiment.
That makes sense. That makes sense. The next question I had was, as we are moving towards pre-confirmations, we unlock a lot of amazing features. But I was curious about the point where you were talking about the pre-confer fee and how wallets might integrate that. Like, is that an actual value that you're going to be setting? Is it similar to the base fee where it's always the same, or like will wallets need to upgrade for users to then input how much they're willing to pay for a pre-confer fee? Maybe it's too early to know. I just want to understand from your perspective.
So let's talk about from normal users that they don't know anything about the technical stuff. So just as a user, I will use MetaMask. So MetaMask need to implement this UI, so add more to pay the pre-confirmation tip. Yeah, MetaMask needed it, but maybe it can be hidden into priority fee, maybe because priority fee will go to the proposer. So base pre-confer will be my proposer. So if I pay priority fee, so I can say I'm also paying pre-confer tip. So if I increase the priority fee, so that means a pre-confer tip. So
Gotcha.
Maybe we don't need to implement MetaMask or anything.
Okay, yeah, that makes sense, because I think from a user experience, from a new user experience, like blockchain can be complex as it is, and to add another field in there for them to figure out, I think
this is another problem to be need solved, because from common users, it's very hard. Let's think about it, because do I need to use Arbitrum? Do I need to use Optimism? Do I need to go Solana? So there is no connection. So we need to solve all of these user experiences.
Yeah, that's great. And yeah, with these shared sequencers being on layer 1, it begins to open up the longer term vision of Taiko in the concept of a base boosted rollup, where we have asynchronous or synchronous composability, and we can have those messages cross.
Yes. Composability can be synchronous or asynchronous. So internet works as asynchronous. So synchronous or asynchronous, we had to need it in any way. So yeah.
Awesome. Okay, so I wanted to touch on, there's a couple kind of questions here. I'm going to combine them a little bit into one, and maybe let's start with the concept of the different types of rollups. I know Vitalik has an article about type 1, type 2, type 2.5, etc. So can you give us an idea of where Taiko is now, what type we are, and I guess kind of the trade-offs that we have made, and the direction that we're going to rise up the ranks of these types of rollups?
So yeah, you're right. Vitalik proposed the idea of the types of ZK EVMs. So previously, at the beginning time of Taiko, we contributed a lot to PCE. This is a sub-team of Ethereum Foundation's ZK EVM. So there was ZK EVM by implementation by Ethereum Foundation. Then Scroll and Taiko born as a new startups building ZK EVM is a different type. So we left and deprecated from these ZK EVM, because currently we have ZK VMs. So in ZK EVMs, you need to write a specific circuit for EVM. So you need to put all of the EVM into the circuit, but it's not very efficient, because EVM is not built as ZK friendly. So we need to change some of stuff of EVM to make easier to build ZK EVM. So, but it's for now, it's very hard. But now VK ZK VMs, you can run any code. It can be Hello World code. It can be Rust Ethereum code. It can be anything. You can prove this line of codes, some line of codes, by putting into ZK EVM. Then you will take ZK proof. So I can say ZK proof is ZK VMs is very efficient, and it will be. We don't need ZK EVMs anyway, and these if you put Go Ethereum client, like get client into ZK EVM, we will have type 1, and there is 0 called as type 0, but they are same thing. You don't need to change anything to deploy EVM contract to the type 0 or type 1 ZK EVM. Taiko is a type 1 ZK EVM, but we have no ZK right now. As I said, we deprecated from ZK EVM, but we will implement ZK proofs at the end of year. So we will be ZK type 1 or type 0 ZK EVM.
Okay. So yeah, maybe can you reiterate in like a concise manner the types that that we want to be and where we're at, and like I guess maybe a steps towards those things.
No, it's not steps. It's understandable. EVM has some constraints in terms of performance. So it's not a foot, but we need to know that. So as I said, for example, it's not snug friendly. We need to change something on the EVM to implement ZK EVM. But for example, let's talk about StarkNet. They built new ZK VM from scratch, and there is no connection with Solidity. There is no connection with EVM. So they are more performant than EVM itself. That this is the spectrum. If you have type 1, you will have directly connection with EVM and Solidity rather than changing anything. But if you have type 5 or type 4, you will have your own developer ecosystem. You will have your infrastructure from scratch. And this is the idea.
I see. Okay. So it's not pardon me, it's not a graduated system, but it's the ideal is to be a type 1, I guess from our perspective, that being completely Ethereum equivalent, meaning we changed very little to the EVM. Is that
nothing? Change nothing. Yeah.
Okay. Absolutely nothing.
So it depends on your mental model. What do you want to be? So if you be type 1, you can inherit all of the infrastructure directly without changing anything. So, but you will have less performance, for example.
Okay. And so currently Taiko is a type 1 by the definition that
yes, definitely.
Amazing.
And actually, there is no type 0. It's just a new term, but the real term is type 1 and type 4 and between. So we can say type 1.
Amazing. So we've reached that benchmark, and now the challenge for us is to scale our solution a little bit better, because right now we're beholden to Ethereum block times, as you mentioned, 12 seconds, which sometimes ends up being a little bit more than 12 seconds, just as things get ordered, essentially. But so, with pre-confirmations, you're going to be able to go faster.
Yes, on the demo at the testnet and DevNet, we can say internal testnet. It's called Helder. So Titan is our partner to build pre-confirmation POC. So they have 20 millisecond block times. So for example, Arbitrum is 200. So Taiko's pre-confirmation is 20 milliseconds. Yeah, it can be. It's still on DevNet, so it can be higher, but still we can say we have block times same as Arbitrum, so as a base rollup. So this is the beauty.
That's awesome. Now, are there any trade-offs for that? Like, because it becomes an opt-in system where these layer one nodes need to opt in. It's not necessarily, we're not reaching the entire L1 node population, right? So does that change at all, like the security guarantees or how like we're modeling this?
Yes, if you integrate base pre-confirmation, you won't have same security as native based rollup. But still, this is the main point. Our pre-confirmation provider coming from L1. So we are our first idea is Ethereum is the most secure, incredible, and neutral layer. So I'm using a part of L1 as a pre-confirmation provider. So this is the main point. It's still base rollup plus base pre-confirmation still have more security and more liveness than any other centralized chain and any other decentralized rollup, because if you don't want to be based, you have to create your own consensus on L2. So you will have less security, as I say.
Gotcha. That makes sense. And I guess, like, theoretically, the longer that Taiko runs, the more exposure we get, the more validated our idea and architecture becomes, then more and more L1 nodes would want to opt in to be a pre-confer. And as that happens, security also increases. Is that reasonable to say?
Yes. Wait a second. Yeah. So, as I said, the upcoming fork, we will distribute the large percentage base fee to the proposers and plus pre-confer fee. So when you see this end game for in terms of economics, so any L1 proposer want to be a part of Taiko blockchain, Taiko L2. So yeah, we can say that.
Amazing. Okay, that really helped me wrap my head around where we're at and where we're going, and I think it also addressed some of the questions that we had in the chat. So thank you everybody for bringing those questions forward. And I think I think that's it for questions on my end. So we'll start to wrap up here. Was there anything else that you wanted to leave folks with? Any maybe articles that you're working on for people to keep an eye out for?
Yes, as you see here at this page, I will work on base rollups economy or economy of base rollups. I will mention all of these stuff, the MEV revenue, priority fee. I will mention all of them. So also I will introduce some insights and some data from Taiko, the current Taiko data. So how a base rollup can be profitable, which situation L1 gas, how much you need transaction, L2 transaction. So I will bundle all of them and we'll write this blog post. So stay tuned, I can say.
Amazing. Yeah, I'm looking forward to that as well. All your articles are very
internal education.
Yeah. Perfect. Okay, so thank you very much, Jünger, for being here and educating us all and giving us an insight into where Taiko is and how we're adding value to Ethereum long term. Really appreciate it.
Thanks for me. Thanks for inviting again.
Of course, yeah, for sure. For everybody else listening, thank you for being here. And if you have more questions, please find your way over to the Taiko Discord, and we're always there ready to help. And if you have more questions specifically for Jünger, we can tag him and make sure that he's there to answer. we're under a month left, so definitely go out to the DoraHacks details page if you haven't already. Read what we have on offer. There's tons of ideas there for you to work on. And again, you can come over to the Discord if you're a developer and you're looking for a team, or if you're an entrepreneur, a marketer, a designer that wants to contribute to another project and work together. Come on over and we'll get you sorted out and paired up. And there's still plenty of time to get your projects ready and polished up and submitted for the hackathon. I'm gonna shoot it back to Mishika if she has anything left to add.
No, I think that's all from my end as well. And yeah, thank you, Jünger and Jordan, for hosting this workshop. Really appreciate it. And good luck, everyone who's building in the hackathon.
Awesome. Thanks, everybody.
Thank you, everyone. Take care.
Bye-bye,
Bye.
guys. Thanks.